Okay. Welcome to Upstreaming 101. Took a second there because I like to wander a lot when I'm talking and use my hands. So, okay, a little overview today. I think the previous session set you all up. If you're new to open source communities and so forth, a lot of great general background. Get a little overview of what we'll talk about in 101 is the target audience is developers mostly, but also engineering managers. It's just as important for engineering managers to understand what their developers, what their employees are going through when they're upstreaming and what the requirements are. So our focus is to keep this laser focused is we're only talking about kernel upstreaming. In the previous session, we talked a lot about communities in general and so forth, but here we're going to talk just about kernel upstreaming and particulars of the kernel community itself. We'll talk about what is upstreaming, because surprisingly, or maybe not unsurprisingly, there's some confusion as to what that means. And we'll also get into the meat of this is how to upstream, the actual mechanics, the social aspects of it. So prereqs, typically expect that people are familiar with source code control concepts. In particular, usually people who are wanting to do upstreaming in the kernel probably already are technically adept in working with Git and so forth, and that's really a critical part of this, and of course a technical understanding of the kernel. So that helps to follow along with this. So what is upstreaming? And when we're talking about it here again, we're talking only in the kernel context, not any other community out there. Every community has their standards and how things are structured. Upstream simply means to move software into the top level Linux repository. Right? And this top level repository is Linus Torvalds repository, also known as mainline. So what is mainline? This is a point of contention. A lot of people I've met in the past and teams I've worked with in the past have companies where they might refer to some tree inside the company as mainline. XYZ member companies mainline. And that is not mainline when we're talking about upstreaming. It has nothing to do with your company trees or anything like that. Where we get that term from is right here. You go to kernel.org, that's where that term comes from. It's best not to use that to refer to anything else in the kernel context. It simply confuses people. I can tell you that management at least 3 different companies I've been at have found that very confusing when the internal tree is called the mainline tree, the main one. So that just really confuses things as to what it means to move things upstream and into mainline. Train people to only use Linus Torvalds' tip of his tree as mainline. And if they're confused, you just point them right at that website, and that's where it comes from. So who contributes to mainline? So if you're going to do this, you want to know that you're in good company. You can take a look here. I haven't bothered updating this. It changes just slightly every time they do these. And I said, this time I'm not going to update it to the latest. But back 3.16, you can see a lot of big names and some small names. And if you're not doing upstreaming already in the kernel, if you start doing it, you can land yourself up here in this top list as well. But the reason I show this is to show you that lots of companies are doing this. These are the top contributors by company. It's something that people have justified business reasons and so forth. We don't get into the why to do upstreaming. I assume that you've already come to the conclusion that you need to be there and you have good business reasons, because all these companies have valid business reasons to be doing it. So how do we swim upstream into mainline? So the way the kernel works is there's a distinct hierarchy of repositories. Okay, these repositories are managed in Git, the source code control tool. which I expect you to be at least remotely familiar with. And there are one or more topic branches within each of those repositories that feed into the mainline kernel, Linus Torvalds kernel. And each of those repositories will have different owners. Sometimes one owner, sometimes it would be a maintainer that owns many different trees. And sometimes there's a team that manages a repository. It varies based on the area you're in. So let's take a look at typical areas in the kernel and how the code comes up. So we say you have some changes here. There's some different categories of maintainers, I'll call them. You have typical, like a larger driver. If you take something like DWC3, right, USB, that's such a large thing, it will typically have one maintainer that just, that's a very big focus for them. And your changes may need to go to that driver maintainer. If you're modifying that driver, that maintainer owns those acceptance of those changes. And then we take features, areas like networking, where David Miller owns everything in networking. Architecture maintainers, we have ARM SoC maintainers, right? We have the core maintainer, Russell King. We have ARM SoC maintainers. And then you have subsystem maintainers. You have things like regulator with Mark Brown and pin control with Linus. And then all of those feed up into Linus Torvalds tree. So let's talk a little bit about maintainers, what they do, their roles. So as I pointed out on the previous diagram, you have they're component code owners, right? And for each of these areas, you'll have one or more of those. And as I pointed out, they fall into subsystems, have a maintainer, individual drivers, file systems, right? And architectures, and also platforms that need a lot of support will have their own maintainers. So each of these component code owners is responsible for some portion of the kernel tree. They own that tree. They're the gatekeepers. They are the ones that control acceptance. If you're going to modify code in their area, they have the final say as to what changes in there. And the important thing to note is the acceptance criteria can change. Some maintainers are a little bit looser on style. Other maintainers have certain ideals of how they want their subsystem to work, the style, the layout of it. So you need to be very familiar with what each maintainer wants in their area. To quantify it a little bit, to give you an idea, this is probably back in the 3.12 era I ran this. You can run it yourself, how many unique maintainers there are in the kernel. You can go look at the top level kernel tree in the maintainers file. Even back then there was 912 unique maintainers. That's a lot of people. It's a lot of different areas. It just shows you how the hierarchy works. So each of those subsystems, those components, have one or more maintainers. Each person that's a maintainer is listed in this file, and you can see it's a very well-formed entry. Right? So you have the email, you've got any list for an area that if you need to send patches, there's a mailing list. If there's a website, there's an entry there, and then a status of that area. There are things that become orphaned if a maintainer loses interest or they move out of an area, and you can have certain things that are listed as orphaned, right, or unmaintained. And then the final important thing is you'll see like this where ArchArm, right, for Russell King, he owns everything under there except the ARM SoC board area and so forth. But if you ever have any questions about what you're modifying, who owns it, it's all answered in the maintainers file. So the next thing we need to understand, now that we know about maintainers, what their role is, we really need to understand how the release cycle of the kernel works. because we need to understand that cycle to know when we submit our patches, when we can expect them to be accepted, when they can be merged, how they appear in Linus Torvalds tree. So merge windows, they open about every 10 weeks plus or minus a week, okay? And they're very predictable, but there are times where Linus is on vacation, he's on holiday, and you know, things will slide an extra week. And that's the times where you'll see, if you look back at the history, you'll see something go not to RC8, you'll see it go to RC9 if you look back at the different release candidate history. Once that merge window opens, it's open for exactly 2 weeks. That does not vary. New functionality, and keep this in mind, this is the key to your work, is the new functionality is only taken in that 2-week window. The only thing that can be taken in outside of that window is bug fixes, clear bug fixes. So all of your efforts have to be tied around having things accepted by maintainers and ready to be sent to Linus Torvalds before this 2-week window opens. So now that we know that, an important part of your work becomes planning your efforts around the merge windows. And so if you're thinking about developing software to get in the kernel, you need to think in a way of your planning or your team's planning of when does the merge window fall and what can I get done before this point. So if you're thinking about, you have a manager asking you, what kernel is this going to be in? Well, it's not going to be in the one, if you're just starting developing something, it's certainly not going to be in the one that's about to have the merge window open in 2 weeks. That's certainly not enough time to get a new feature in the kernel. So the key here is you're not going to do it 2 weeks, start something new 2 weeks before the merge window opens. You need to have new functionality accepted in that maintainer tree, whether it's that a maintainer that owns a driver, a subsystem like regulators. It has to be in there by, say, RC6 or RC7. Okay, that would be the 6th or 7th week after the previous merge window closed. Okay, after RC7, most maintainers, this really varies again by maintainer. Most of the maintainers are only accepting fixes after that. They want to stabilize the areas that they own because they don't want to introduce any risk into their next merge to Linus's tree. So the end result of this is you have less than 7 weeks after a merge window closes, okay, to have a maintainer queue a patch for the next merge window. So what this looks like, if you look at the rolling cycle, again, we're back in the 315 to 317 era, looking historically. This is true as we go. When the merge window closes, that's the day RC1 is released, right? And every week, you have, whether it's Sunday or Monday, you have another RC released through that cycle until you get to the 315 here released. That starts that 2-week window again, okay? So we'll talk a little bit about how to upstream. Well, not a little bit, how about a lot? We start, real key is preparing. Preparing, we talk a little bit about merge window planning, but preparing, understanding what you're going to create, creating the code and the patches, how to post, how to handle feedback, what do you need to do with maintaining things, and also how long does it take. So preparation, this is by far the most important thing here. If you do not prepare properly, you're going to have trouble upstreaming, and I'll elaborate a bit on that. You need to know your content. One of the problems we see is people trying to submit patches by proxy. And what we mean by that is if somebody else has written the code and you don't understand the code and you don't understand why something was written the way it is, it's more than likely that some maintainer is going to ask you, why did you do it this way? If you don't know, there's no way that patch is going in. if they've got a question. That's a red flag right there if something looks odd. So don't expect that if you don't know why you did something, that you could possibly get the code in. So you need to know why you wrote code a certain way, why you made certain decisions. You need to look at existing kernel frameworks. You need to look at existing drivers, whatever you're merging into, and you need to fit your contribution into that framework. Doing things that's outside of the norm is going to be a red flag to maintainer. Right? Most of these subsystems are very mature. There's good reason why the frameworks are written the way they are. There's a lot of commonality in these parts when you're thinking about drivers or architectures. And so the key is you need to focus on understanding what the current standards in that area are, and making that contribution, that source code, actually conform to those framework standards. Okay? Using current kernel APIs, not duplicating code and making up your own. And then the other thing is, you can't just look at this statically. You can't look at, say, a 318 RC kernel or a 319 and say, the way the framework works right now is this way. You also need to be aware of who's doing work in that area. If somebody is, to take an example I've run into, if somebody is working on a PHY framework and you're writing something that uses a PHY and you're not aware of their patch series that may be 9 revisions in and is about to be accepted in the kernel, you may do a lot of work oblivious to that PHY subsystem and then have to rewrite all your code, right? And then you got to go back to your manager and say, well, I got to spend all this extra time because I wasn't paying attention, right? So you want to look good, you pay attention to what's going on upstream, what's going on the mailing lists in the area that you're working in. It's not enough just to look at the kernel as a particular release. It's also what's going on in the development cycle. So how do we learn how these subsystems work and everything? The starting point is always documentation. There is a lot of documentation. In my past of mentoring people on the Broadcom landing team, I found that probably greater than 50% of the questions I got were all answered in the documentation directory. Go read the documentation on the area you're working on. There is a lot of stuff in there. Pretty much every subsystem, drivers, device tree bindings, there's documentation on all of it. Not necessarily going to answer every question, but at least greater than 50% in my experience. Since we work on ARM, a lot of people will need to deal with device tree bindings. There's documentation all under the device tree bindings area. You can see best examples there. It's always an evolving area. So keeping up on the mailing list, right, is an important way. You can take a look at the device tree mailing list, highly recommended if you're dealing with a new platform and need to define new bindings. You learn a lot about what the current standards are there. So as I was saying, it's important to keep up on what people are doing right now in the area you're working in. So you need to be aware of what mailing lists and IRC channels things are discussed on. Again, back to that maintainers file, I showed you how an entry looks. You can go see a mailing list, right, for pretty much every subsystem. Major subsystems that you might deal with, there's a mailing list. You can subscribe to that. You could read it online. There's plenty of archives, ways to do that. But like the PHY example I gave, if you keep up on that area, whatever it is, then you'll know that major changes are happening that may affect the code that you're working on, and that'll help you from redoing work needlessly. And sometimes you'll find things that don't make sense, or maybe you've got that thing that's a little bit different than from what anybody's seen before. Ask questions. It's not a read-only These are not read-only forums. The maintainers want you to ask questions. Right? If you've got something different, ask questions. They get you steered in the right way before you start writing the code and go down a path that's going to waste a lot of time. Right? Recommend anybody doing ARM work reads Linux ARM kernel at a minimum. It's a good one to be subscribed to. And then the #ARM Linux channel on Freenode is a great resource if you need to. Most of the ARM related maintainers, whether they're subsystems or ARM SoC maintainers, are there. If you need a quick clarification, that's a good place to get it. Okay, so that was a lot on preparation. So now let's get into creation. Since I love documentation, I list it all here. You want to read and understand all of these. Submitting patches, right? That's the canonical standard. It's updated fairly regularly for things that are clarified or a modification, slight modification of the process. Nothing major has changed a while. There's a submit checklist that's helpful. And then device tree has a couple quirks to the generic submitting patches that they'd like you to do. And then something I was reminded of a couple weeks ago and threw in here is a great thing to read is Greg Crowhartman's series of How to Piss Off a Subsystem Maintainer. Go take a look at his writing on that, and it's pretty good advice of how to make a maintainer happy. They're very busy, and really that's the gist of what he talks about in there, but I highly recommend that. It'll help you a lot as you're getting ready to create patches and deal with the maintainers upstream. So when we create patches, I talked about Git, everything in the kernel. Everybody maintains their repositories in Git. So if you have some other source control tool you use in your company, quit using it for upstream work. You will use Git. Your life will be easier. You will not be productive if you choose to do something other than Git. All of the tools for submitting patches upstream are all intimately tied around Git. So just use it. The key to sending patches upstream is as you're developing your code and you're committing things and you're dividing things up, when you make commits in Git, you want to do a logical division of commits. And what this means is you want to take small changes, you group them by functionality, and each one should be individually complete. And what this means is they have a term in Git bisectability. And what this boils down to is that when you divide all your changes up, each one, if you apply them individually in order, should not break the build. It should also not break runtime. Right? So if you have a series of 10 commits, every one of those successively should build and not break the build. Okay? So you may have a typical thing when we think about logically dividing commits. If you were to write a driver, but it required changes to a subsystem and maybe a bug fix, and it depends on those, you would divide those up into, here's the bug fix, here is maybe an additional API I'm submitting, that would be in a separate commit, and then the new driver as a commit, okay? And we'll talk a little bit more about how that looks in examples and so forth. In 201, we look at some real specific examples. The reason that this is needed, if you think about what a maintainer goes through, if you were to drop them a commit with all of that stuff in one place, it's very hard to see why an API change. There's an API change mixed in their subsystem, plus this driver, plus there's a bug fix in there. Well, where does it begin and end, right? They need it logically divided, and you're battling for that maintainer's time. They're doing this usually in their spare time besides their regular stuff, and so your challenge is to get their attention, and you have to do the hard work of having everything well presented, explained, divided up to make it easier for them to review and decide that your code is worthy to get into their tree. Okay, so when we create a patch, now we're getting into some of the mechanics of it. If you follow the list, you'll start to see these standards, and these are all, they're covered in that submitting patches documentation. All right, so if you have any questions, I give an overview here, but it's all in there, all the details. If you're doing a multi-part series, I talked about dividing things up into logical commits. Each of those commits becomes part of a series, in a multi-part series. So in the previous example, we would add 3 commits, and it would look something like this, where, you know, patch 01 of 11, that would be, you know, 01 of 3. And then there's a, you would tag it with a subsystem. So let's say you were doing something in the regulator subsystem, you put regulator and then a summary phrase, right? Which is a short description, right, that stays with that patch forever, that explains roughly what it's touching, what it's doing. And then another subject line. This makes it easy for people to read the list, to scan through with this well-defined subject line. As you evolve your series from comments, you're going to go through revisions. There's a standard for putting v3, right? That would be version 3 of that same, of a standalone single patch. And then if you have an idea of how to change something, but you're wanting to, you can show it in code, which is often recommended, but you don't want the maintainer to think that you want it merged in. It's more of a, here's a request for comment on solving this problem a certain way. You tag it with an RFC. That signifies to them that, hey, this person doesn't want it merged. They're just saying, hey, this is how I solve this. Maybe look at it. It's a great way to do that, and gives them an idea of what your intention is. Critical thing, and had a discussion with a couple people, a couple maintainers about this yesterday. Take the time to write a quality commit log message when you're doing your development. It's good practice for just keeping notes when you're actually doing your development as you go along, but when you're getting ready to submit, you really want to expand this out. You need to tell the world why this patch is needed in your commit log, what the patch implements, how you implemented it. Sometimes it's a little subtle of how you did something or why. You know, there's a little bit of each. I give an example in very generic terms, but if there's a bug in something, you have to explain what's not there, right? Add and what you did, why I added this additional path to handle something. Each commit has to have this. You will not get things merged without an explanation of how, what, and why the patch implements code or a solution. As I was saying, use Git. You've got format patch built into that. When you create a multi-part series, like we were discussing, you have a set of these logical commits that are separate patches. They all add up to solving some problem or adding some feature. Your cover letter that goes in front of that will appear as patch, well, there'll be a cover letter, and then you have the patches 01 through whatever the end. The cover letter is your opportunity to tell what the whole series does, okay? Again, it's excellent practice, and nobody will ever fault you for writing a novel in that cover letter. The more information, the better, because most people err on the side of not having enough. And then the maintainer has to come drag the information out of you. Very easy to lose their attention, very easy to be seen as wasting time. So purpose and scope of the entire series, that's what you're accomplishing there. Take a look at the mailing list. If you read Linux ARM kernel, you'll see that as people do things. You'll see a 2-page long cover letter explaining a complex series. Right? In the scripts directory in the kernel, check patch. You use that to verify coding styles, semantics. There's a lot of companies that already do this internally for their internal trees. That's a must-have. It's very pedantic. It's a good thing, but it'll catch all your white space issues and things like that that are common for beginners. Things that are super annoying to maintainers that have all this automated, because first thing they do is they run it through their script and try to apply it, and it kicks out, and they have to manually type you an email and tell you that you did it wrong, right? Then you also have scripts get maintainer. When you've created the patch using like get format patch, and you're wondering, well, who do I need to send this to? You run scripts get maintainer on that patch. Well, it processes that maintainer's file we looked at earlier, and it will tell you everybody, all the individual's emails and the mailing list email addresses that you should send to and CC. All right, so we've created patches. We need to post them. So to post a patch or a patch series, I recommend put the maintainers on the 2 line, put mailing lists on the CC. A lot of people do this differently. There's a bunch of different ways. My attitude's always been that the etiquette of email is people on the 2 line, I want to take action. Those are my maintainers. I want them to apply my patch. People on the CC line, those are interested parties, right? People on the mailing list that might want to comment and so forth. Maybe colleagues at work that need to follow your patch submission. And then you can use get send email to post the patches. And now the hard work begins. And this is the thing that people don't seem to understand, is that you've done all this work to the point, you're proud of your code and everything, but you're barely started at this point because you're only at version 1 of your patch. So expect comments. If you set your expectations that you're going to get comments and have to do some rewrite, then you'll be a lot happier in this process than if you go in thinking that someone's going to apply it the first time you submit. So dealing with feedback on mailing lists. We do everything on mailing lists in the kernel community, all this review process, everything. The first thing that's going to happen when you post that patch, you got this beautiful shining code, you're proud of it, it's amazing, it's well done, and you post it and nobody says anything. And you wait and you wait, there's just no response. Be patient. And when I say be patient, right, maintainers are very busy. We talk about, doing everything right, making things easy on them, but you may have somebody on holiday, you may have somebody on travel. There's a lot of different things that can happen there. Wait a week. The etiquette is to wait a week before you repost something, okay? You can go, I suggested HashArm Linux. You'll find a lot of folks on there. You could go pop in and say, hey, is Mark Brown around? And somebody will say, oh, he's on holiday, right? People are eager to help with that, but you do need to be patient. One of the things, if there's been people in the past that they don't hear anything in a day and they repost the day later. The turnaround time on these things can take a while when you need to get that initial, take some time for a maintainer to review a patch thoroughly, so they may have a lot in their backlog. So the next thing is, and this goes all the way back to what I said about submitting by proxy. Know your material, right? Tough questions. Be prepared to be asked every intimate detail about the code. Back to the log message I said, what, why, and how. You better know what, why, and how, right? They're going to ask you exactly why you did this, how your hardware works, if you're doing a driver. Why do you need this different thing? This is completely different from everything else. You need to be able to explain everything in detail to them so they have a good feeling as to, are you doing something wrong or ignoring, an API, or is this really something that's different that I need to compensate for in my subsystem, right? Be aware that as much as nobody wants to admit that they're incorrect, maintainers aren't always correct, right? You might have something that's different and you really need something new. So if you know your material, be strong, concise, in your explanations, and why you needed something. You know your hardware best or why you did something. If you don't understand a comment, ask for clarifications. It's a huge problem where people just, get a comment back, they don't feel comfortable asking a question, and they submit a second revision, and they didn't understand the comment. Just ask for clarification. I mean, the maintainers want you to modify your code to fit their comment, so they'll be happy to clarify it if it was vague, right? And then the big one, do not ignore comments. There's a lot of people that will simply don't understand. It's not that they, maybe they don't understand or they don't like the comment, and they just submit another patch and just ignore it completely, right? And I've heard from several maintainers that just annoys them because you don't acknowledge it, you send another rev, and then they find that you didn't address the comment in there, right? Really a way to start getting ignored by the maintainer. Okay. So when you're doing, you're handling feedback mailing list, you need to use a sane mail user agent like Mutt is my recommendation, but you can get advice on configuring all these different mail programs right in the documentation directory. There's all kinds of advice on how to use Thunderbird and all these other ones to get when you're replying back, you need to wrap at 72 columns. There's great advice in email clients of how to do that. So pretty much exact steps in there. One of the big things is that people worry a lot about getting flamed. Right? It's a big thing. We always hear that you'll have the kernel panels at LinuxCon, and that's a big topic of how mean Linux is and everything. And the reality is that doesn't happen with newbies. It just doesn't, unless they're not listening to advice or something. But it's always the people who should know better, right? And it's kind of blown out of proportion in the kind of industry press, if you will, the different blog sites and so forth about semantics. But it's generally with senior developers and so forth that should know better, and they get in arguments. So you just don't need to worry about this type of thing. It doesn't happen. All right, so when you're getting that feedback, now you've got to make some changes, right? You've got some feedback from the maintainers. Be responsive. You've got their attention. If you go off and get sidetracked into some production issue for 3 weeks, 4 weeks, 5 weeks, 6 weeks, right? And then you come out with V2, the maintainer's forgotten about you, right? Oh, well, they must not care that much. Or now you're back down on their backlog, right? Also, their comments that they made aren't fresh in their mind, right? They're like anybody else. They're dealing with a big load. So if you can turn around those comments and get a V2 out based on what they wanted very quickly, or you need clarification and you get back to them and say, wow, what do you mean by this? If you can respond quickly, keep their attention, right? You have a better chance of moving that patch series along quickly, right? So yeah, get those comments incorporated quickly, turn around a new version, right? Just be prepared that this can take several iterations, okay? Don't expect that, like I said, V1 is not going to be right. V2 may not be right. Somebody else may jump in by the time you get to V4 and have some other comments, right? Expect many iterations, right? A lot of first patch series, or depending on you can't really say that something will go, take four revisions just because you've sent patches before. It might be something more complex or controversial or in flux, So you could easily spend 10 revisions, which, can take months to go through. So as we showed earlier in the subject lines, you increment the version number in the subject line every time. Part of Git format patch will do that for you. really nice tools. They're all well documented. Okay, so let's assume we got our patch series accepted. Now what? Well, now you've signed up for some work. So you have a certain obligation at that point. Perhaps you've put a driver upstream. Well, you've got an obligation to maintain that. That's a piece of code that you put up there. You know it best. If it's a driver, it's hardware you've worked on. Keep aware of those mailing lists, changes that are happening in areas. You may get CC'd on something where someone wants to change a kernel API, right, that also touches your driver. So you're going to start having some traffic on that, right? Help review changes maybe. Maybe you've done something in the regulator framework, and maybe you can help out by reviewing other driver submissions, right? And test, because now if you're doing this upstreaming, you don't want anybody to break your stuff, right? So if there are subsystem changes, you should really verify that they're working okay on your part before they go into the kernel. So in summary, preparation, that was probably the biggest part of this, was really knowing the stuff, right? Knowing your kernel subsystems, knowing the APIs, knowing what the expectations are for the particular area of the kernel you're modifying, right? Read the fine manual on everything, right? Documentation, right? And then clarify things on the interactive forums we have. Ask questions. Biggest curse is people who feel that, it's a dumb question, right? It might be, but you're not going to know until you ask the question, get the clarification. It sure beats writing a bunch of code, going down a path, and then finding out that you just wasted 3 months and you got to, 3 weeks or something, and rewrite the whole thing. Act with a sense of urgency on the comments, right? Get that next rev out, keep the maintainer's interest, and really understand that merge window timing, right? If something's going to take you 2 months to develop and get in shape and everything, you probably can't expect to start it, a month before the next kernel comes out and get in that kernel. It's going to be in the next revision, so be aware of that. Okay, and that's it for 101. Any questions? We're going to continue on with the 201 here after a break, depending on which it gets into a lot more depth and examples. We're good on time. Yes?
One question. If I submit series of patches and then maintainer asks me to change one of them, what is best practice? I submit all changes, all series with version 2, or just patch I modify?
You want to redo the whole series. Resubmit the whole series, unless the maintainer says, hey, I've picked up these ones, right? Occasionally that happens, but usually you'll just, if it's new, he may not be ready to accept it right away, maybe giving it some time for some other people to comment on it, right? And so you might want to wait a day and resubmit a V2, right? You change the one, and then what you do is best practice, and I'll show some examples of this in 201. 201 is very driven by examples, okay? We'll look at some real emails and style, and I'll show you an example of this. You would update a changelog in the cover letter indicating that you updated this piece, and that keeps everything. Oh, they apply one of them.
Yes, and suddenly I resubmit next version, and suddenly can you stop using your patches version?
Yeah. Mark sound like.
Only resubmit the ones that haven't been applied.
Right.
If it's been applied, that's good. Don't need to send them again.
Yeah. Usually what you'll get is the maintainer will say, I've picked up patches 3, 5, and 7, and so you would drop those out, right? Bug fixes or something in there.
Under those circumstances, when you resubmit the one that was not applied, does that still
Well, if you still have a series, then you could have a cover letter and you could say this is dependent on X, Y, Z that are merged and merged, and you can give the subject line for that got merged because it's not committed yet, right? It's in their tree, so you've got something, say, for regulator tree. I keep using that example, right? This depends on these 3 patches that we're taking in.
If it doesn't depend on any of the others.
Yeah, let's say it's just one, you would just, rescind that patch and say it depends on these things that were merged in the regulator tree. Yeah.
In my case, I submitted a series of independent patches to extend coverage on different architectures. This was actually for meta open embedded live HTLBFS. Most of them were accepted. One of the patches I didn't hear anything from for a long time. When I finally pinged the guy back, he said, that one broke the build.
Okay.
And I said, well, didn't break the build here. And he said, well, if I get time, I'll retest it.
Right.
And haven't heard anything back, and it has not been merged. So.
And maybe a configuration difference or something like that.
I took, just to make sure that wasn't the case, I took their newest tree and just built that particular recipe alone without, it's normally part of a bigger recipe for a file system image. And I thought, well, maybe there's some other dependencies or something there that makes it work in the context of the file system image, but not on its own behalf. So
Right.
I tested it that way. It still didn't break.
That's,
No changes to the patch.
yeah. That's one of those unfortunate anecdotal things where you got to somehow find that way to come to that conclusion of why you have a difference. Yeah. Any other questions? I should have you run the mic around for that, but that's, yeah, if we have another. Okay. Well, we'll give it a couple minutes and jump into 201. That's where we make fun of postings.